Okay, these are going to be our notes for shape of data distribution. This is chapter 10, stop 9. Okay, so shape of data distribution. The distribution, that's right here if you need to know how to spell it. The distribution of a data set shows the arrangement of the data values. Okay, so basically the distribution shows the graph, how it's laid out. Data are symmetric when the left side of the distribution looks like the right side. Okay, so when the left side looks like the right side. So we say a heart, typically if you drew a perfect heart, would be symmetrical, because if I cut it in half, the left side looks like the right side. Okay, same shape. All right, the next one, a cluster is data grouped closely together. Okay, so a cluster is when they're close together. And the next would be a gap is a number that does not have a data value. So if there's not a dot or the graph is not graphed on that number, then that would be a gap. And then the last one would be a peak is the most frequently occurring value. And we know that the one that occurs the most often is the mode. Okay, so a peak is the mode. Think of like a mountain peak. That's the top of the mountain. It's the highest point, so it's the one that occurs the most. Okay, so let's do some examples. Example 1, the dot plot shows the quiz scores in a social studies class. Describe the shape of the distribution. So we're going to look at this and we're going to say, is the shape of the data symmetric or not symmetric? So if I kind of cut this data in half, does that look symmetric? Does it look the same on both sides? No, that does not look the same on this side as it does on this side. So the data is not symmetric because the left side of the data does not look like the right side. This side does not look like this side. Okay. There are clusters. Remember, clusters are when it's data grouped closely together. So here's a cluster right here from 17 to 19. From 17 to 19. And then here's a cluster over here from 21 to 23. The distribution has a peak at, we'll think of peak, you can think of the mode, so the one that occurs the most, or think of the peak of a mountain, the tallest point. Well, that looks like that is 23, so it's got a peak at 23. There's a gap at, well, where is there not a data value in this? There's a gap right here at 20. And are there any outliers? Are there any random dots way off here out to the side on either end? No. So there are no outliers. Okay, so now we have this little section in here. If the data are symmetric, okay, so if we would have answered yes, it is symmetric, then in order to describe the spread, we would use the mean. Okay, so if we were going to describe the data, the most effective way to do that would be find the mean. Okay, if the data is not symmetric, we're going to use the median and the interquartile range. So we would use the median and the interquartile range to help us describe it best. Okay, so let's refer to the dot plot in example 1. So we're referring to this dot plot right here. We're going to choose the appropriate measures to describe the center and spread of the distribution. So we're going to be picking one of these. Is it symmetric or not symmetric? Okay, so we said that this graph right here, this dot plot, was not symmetric. The left side did not look like the right side. So the data is not symmetric. The data is not symmetric. So therefore, if the data was not symmetric, we are going to use the median and the interquartile range to show the most appropriate measure to show the data or to describe it. Those are the most appropriate measures to use to describe that data. Okay, so let's look at example 3. Describe the shape of the distribution. So is this data symmetric or not symmetric? Let's look. Well, that doesn't look very symmetrical to me, because here's the, remember on a box plot, this line in the middle of the box, that's the median. So the left side of this is not the same as the right side. So this is not symmetric, okay? It's not symmetric. Not symmetric. So in order to describe it, if it's not symmetric, we're going to find the median and the interquartile range. So the median and the interquartile range, or we call that, remember, the IQR. Okay, so the median and the interquartile range. So if I look at this, the median, remember the median is that middle line in the box, and that looks like it's at 15. The interquartile range, well, this line was Q1 and this line is Q3. So it looks like that's at about 11 and that's at about 17. So the IQR is, remember, Q3 minus Q1. So we're going to do 17 minus 11, which is 6. So since this data was not symmetric, we use the median and the interquartile range to describe it. So the median was 15 and the interquartile range was 6. Now, just looking at this, do you see this dot way out over here? Okay, that is a value or a point at 35. This would be considered an outlier. Okay, this dot is way out here in the middle of nowhere. It doesn't make any sense. It doesn't go with any of the points over here in the graph. It's an outlier. It's just way out in the middle of nowhere. So I just wanted to bring that to your attention to kind of see what that would look like. Okay, number 2, choose the appropriate measures to describe the center and spread of the distribution. Justify your response based on the shape of the distribution. Okay, so we're going to have to justify our response. So that means that we're going to be doing a little bit of writing. So we're going to choose the appropriate measures to describe the center and spread. Okay, so if we were going to do that, we said that this graph right here was not symmetric. So the data is not symmetric because the quartiles, okay, these boxes, this distance, this distance, this distance, and this distance, the quartiles are different sizes. That's how I know it's not symmetric, because this section and this section are different sizes than those two sections. Okay, this half is different sizes than that half. The median and interquartile range are the appropriate measures to use to describe the center and spread of the distribution. To describe the center and spread of the distribution. Okay, so basically we said it's not symmetric because this side is not like this side. And because it's not symmetric, we're going to use the median and interquartile range to describe the center and spread of the distribution. Okay, so let's go back up here and let's visit this graph, and let's just maybe try and find these things down here also. So we figured out that it was not symmetric. Now let's see if there's any clusters. So looking at this graph, can you tell if there's any clusters? Kind of like we could on the dot plot. I'm looking at this graph and I can't tell if there's any clusters because it doesn't tell me every single number in this data set. I only know 5 of those numbers, or 6 really, because there's an outlier out here. So I don't know every single number in the data set. So clusters, we can't tell. What about, is there a peak? Well, like on the dot plot, I could tell there was a peak because I knew I could tell the mode or the most. But on a box and whisker plot or a box plot, you can't tell what the mode is, so we can't tell. Is there a gap? Well, yeah, there's a gap. I've got this number right here, and then I've got this whole big old gap to this outlier out here. So there's a gap from 19 all the way out to 35. There's a gap. Okay, and then we talked about, are there any outliers? Yes, there's an outlier. It's this random point all the way out here at 0.35. All right, so as you can see, you may not always be able to tell if there's any clusters or peaks. Or for that matter, some things you may not be able to tell if there's a gap. Okay, but you want to interpret the graph that you're given to the best of your ability.